In this video, I'll explain the sampler and scheduler components of the ComfyUI workflow and what it does. Let's get started. The first, empty latent image. This node creates a blank latent image, essentially the starting point for image generation. It generates latent, which is then used in SamplerCustomAdvanced. The second, random noise. The random noise component is responsible for creating a random noise pattern. Think of it like the starting point for the image generation process. This noise output, named noise, gets passed on to another node, called SamplerCustomAdvanced. It's the initial input that will help form the image. The third, BasicScheduler. The BasicScheduler is a controller that fine-tunes the process. It adjusts the sigma parameter, which controls the noise level and distribution in the image generation process. It takes in the model and outputs sigmas, which is then passed on to the SamplerCustomAdvanced. Let's break down the functions of steps and denoise in the BasicScheduler. The steps parameter in the BasicScheduler defines the number of iterations the diffusion process will go through during image generation. It controls how many updates are applied to refine the noisy image into a final result. Here's how it works. The diffusion process starts with random noise and gradually denoises it into an image based on the guidance signals. The number of steps determines how many intermediate stages the model will take to refine the image. For fewer steps, the image will be generated faster but may lack detail or appear less coherent because the model has less time to refine the noise into a detailed result. For more steps, the model spends more time refining the image, often leading to higher quality and more detailed results. However, it also increases the computational cost and may lead to diminishing returns if set too high. The denoise parameter determines the strength of noise reduction applied at each step during the image generation process. It essentially controls how aggressively the scheduler removes noise in each iteration. During diffusion, the model progressively removes noise while generating the image. The denoise parameter sets the rate or intensity of noise removal for each step. A lower denoise value means less noise is removed at each step, leading to more subtle refinements. A higher denoise value removes more noise per step, resulting in faster convergence, but a greater chance of losing fine details or creating artifacts. The fourth, KSamplerSelect. The KSamplerSelect component chooses the sampling method. For instance, it could select Euler as the sampling strategy. It outputs sampler, which is then used in the SamplerCustomAdvanced. The fifth, SamplerCustomAdvanced. This is the heart of the image generation process. The SamplerCustomAdvanced node handles the core sampling operation, combining all the inputs, noise, guidance information, sampling method, and sigma values to generate a latent representation of the image. It receives several inputs, including noise from random noise, guider from BasicGuider, sampler from KSamplerSelect, sigmas from BasicScheduler, latent image from empty latent image. The sixth, VAE decode. The VAE decode component is like a decoder that turns the latent image representation into a real, fully rendered image. It takes latent from SamplerCustomAdvanced and VAE from VAE Loader to produce the final image. See you in the next video.